And welcome back to this comprehensive from zero to hero multimillionaire tutorial in which we're going to solve the delegation challenge from Ethernaut from OpenZeppelin. So the goal of this level is for you to claim ownership of the instance you're given. This instance you can access in the console by just saying contract. So the recommendation is to look into the documentation on delegate call, how it works, how it can be used, etc. And also about fallback methods and method IDs, or as I would say, function signatures. Let's check out this code and what it has. It has two contracts. Usually we had one contract, now I have two. We have a delegation contract, or a contract called delegation. This is the instance we should claim ownership of, and it has a public address owner. It stores an instance of the delegate contract. In the constructor you just pass in the delegate contract address and initialize this delegate contract instance, as well as set up the owner to be msg.sender. And finally we have a fallback function which is external, and it simply makes a delegate call on this contract, delegate contract, and we pass in the message .data sent into this transaction. This is not really important. It says if the result, then this. To be honest, I don't even know what this means. So it's common sense that we need to use the fallback function to claim ownership of this contract, because that's the only thing we can call in this delegation contract, because the constructor is already called and these are just state variables. Let's check out the delegate contract. This one also has an owner, so it has the same storage layout as this one. It has a constructor in which you pass in the owner and set the owner to this state variable owner. Then we have a function that you can call, and if you do, you set the owner to be the person who called this function. So what is important to understand and learn in this video is to learn how the delegate call works and why it exists. So what we're doing is here with delegate call, what it does, it kind of like borrows code from other contracts, in our example from the delegate contract, and it executes that code on the calling contract, in this example the delegation contract. So when we say hey delegate call and we pass in the data, this data is basically in bytes, and you'll pass in the first 4 bytes of this 32 bytes in the message.data is the function signature, which tells this contract, the calling contract, which function to call, and it executes the code as it was in this contract, in the calling contract. So it doesn't execute the code, it preserves context. So that's about everything you need to know about delegate call. Now the only thing you need to understand is how to call this fallback function. That's why it says you need to learn about fallback methods and how they work. So whenever you attempt to call, you send a transaction to a contract and you specify a function to call which doesn't exist in the contract itself, then the fallback function gets triggered. So what we should do here is just attempt to call this function and send the transaction to this contract, which obviously wouldn't call any function because this pawn function doesn't exist. That's why the fallback function will be triggered, and inside here we'll make a delegate call with the message.data to this contract, and we'll execute this function on the state of our contract. And it says owner is equal to message.sender, which basically means hey, this first element in the storage of the contract, just set this to the message.sender. And we have a same owner here, which means this owner of the delegation contract will be changed. And before we do that, let's quickly understand why we need the delegate call function in the first place. What do we use this for? So mainly there are two things we use delegate call function, opcode for. The first being calling external libraries and just using their functionality in our contract. And since the blockchain is immutable. Whenever you deploy a smart contract, it stays there forever. And this means that you don't have to reinvent the wheel and implement all the functionality you want in your contract, but instead you can just delegate call. Of course, you need to make sure the contract is safe, etc., etc. You need to audit the library, but it means you can delegate call to any library and just execute that code instead of putting it in your contract, which makes it harder to deploy, etc., etc. That's the first reason why delegate call is used, to call external libraries. The second thing we use delegate call function for is basically to in the delegate proxy pattern. So whenever you want to upgrade contracts, what you do is you do this. You have one proxy contract that stores all the state of the contract, like let's say this is an NFT collection, and you store which address owns which NFT, etc., etc. Stores the state. But how can you make this contract upgradable? Well, you can simply store an address of a contract that can be modified. You just call the code from that logic contract, and you can change this contract, which makes this upgradable. So this logic contract can be address can be changed maybe by only owner, or governance protocol can only change this, because this is very dangerous. The logic contract implies which functions and which code can be executed on this proxy contract. And whenever you want to upgrade this proxy contract, you just change this address, you deploy a new logic contract, you point this proxy to that logic contract, and now you have an upgraded contract effectively. You can check out this code that I'll post in the description. It's very similar to what we have in the challenge. As you can see, we also have a fallback function that delegate call to this logic contract. And also I want to share this vulnerability from this guy on YouTube. You can check the original code here. I just copied pasted this on my own gist. And this is an interesting hack. So we have a vulnerable contract that stores the lib, the owner, and the score. Then what this vulnerable contract does, it sets some score by calling the lib contract, delegate calling to it, calling this set score. Let's quickly see where this vulnerable contract made a mistake, and we can exploit this vulnerable with an attacker contract. We have an attacker function that calls the vulnerable contract set score function. What set score will do is will say, hey library, please delegate call, please call the set score with the argument I passed in. And I passed in the address of my attacker contract. So what this will do is will call the library, and it will set the first element in the storage, which is library in this vulnerable contract. In here it's the score, but the code will be of course executed on this vulnerable contract, and the library address will change instead of the library contract address to the attacker contract address. And once you do that, you can call set score, pass in whatever, and now we're effectively calling the attacker contract and calling this set score function on the attacker contract, which as you can see we have. And we are saying, hey, the owner should be messaged as sender. And this would work because the attacker contract has the same storage layout as the vulnerable contract. And this points me to another error you can make when delegate call is you need to, whenever making delegate call, have the same storage layout, because you can change something else on accident if they not have the same storage layout. So effectively now we've changed the owner to the attacker contract. So now the owner of this vulnerable contract is the attacker contract. And you can imagine how this can be exploited if you have a function who has access control mechanism and has only owner privileges, etc. This is a very good example of how you can use delegate call and make mistake and your contract be vulnerable. Let's now see how we can exploit this contract. So make sure to get a new instance, and when you do, you should have a contract object like so. You can see its address, and we can also see its owner. We need to change this. Currently the owner is not my address. You can see my address is something different. It's F9 instead of 3F. So how can we change this? All we need to do really is to send a transaction with specific message.data that will trigger the pawn function. So let's get the message.data we need to send to this contract, and all we need to send is a hash of the pawn function. This is how you can do this in this console. So this is the bytes data we need to send, and to send a transaction you just say contract send transaction, and in the data field you pass in this. If you click enter, MetaMask will show up and prompt you if you want to send this transaction. This is all happening on the girly testnet. And after the transaction has finished running, you get an output like so. The text changed in the level, which means you've successfully completed this challenge.